Hi fellas, this is Chemaddcts again with the solution. Welcome back to another video tutorial. Well fellas, we will proceed to the next question. So if you have missed the previous episode, don't worry. I will put the link to the previous episode at the end of this tutorial. Okay. So be there with me. Stay tuned. So at first, let us read the question. Uh, Standard enthalpy changes of combustion can be used to calculate the standard enthalpy change of formation of propane. Okay, so here this is, we can see that this is standard enthalpy change of formation. So this is the standard change of standard enthalpy change of formation. This is standard enthalpy change of formation. So this should be standard enthalpy change of formation. Okay. So values for some standard enthalpy changes of combustion are shown in the table below. So as we can see that here the standard enthalpy change of combustion are given for each substances. Okay. So this is the standard enthalpy change of combustion of carbon. This is standard enthalpy change of combustion of hydrogen, and this is the standard enthalpy change of propane. Okay. So in here they said complete the Hess's cycle below to enable you to calculate standard enthalpy change of formation from combustion data. Okay. So in here, this is one part of the Hess's cycle is given the standard enthalpy change of formation here. As we can see that this is standard enthalpy change of formation, since this substance is formed from the required amount of elements. This 1 mole of substance is formed from the required amount of elements. So this is the standard enthalpy change of formation. Okay, fine. So now they want us to complete this data. Okay, so complete this diagram. So we will take the help of this data to complete this diagram. So since all of them are combustion enthalpy, so the other things should be involving the combustion enthalpy of substances. Okay, so here we will undergo combustion enthalpy. So this should be del HC, this should be del HC. So we will going to combust reactants and product. We will combust the reactants. We will do the combustion of reactants as well as the products. Okay. So if we do the combustion of reactants, here carbon and hydrogen is present. So we will get carbon dioxide and water as a result. Okay. So in here there are 3 moles of carbon and 6, that is 3. And don't worry for oxygen. Okay, so oxygen will get cancelled out. So we just uh, written the balanced equation for this reaction. Okay, let me write this clearly. I know my handwriting is really bad. Okay, so this is, and there is one thing that we need to know, that we need to write the balanced equation for this reaction. And how we have came across that this should be the perfect equation for this Hess cycle? Well, in here we can see that the data of combustion enthalpy is given. The only data here is given is the combustion enthalpy. So we just written the combustion equation for each reactant and products. That's it. And that is how we gonna solve this thing. Okay, so that is how the answer should be. So now let us move on to the next question. Calculate del HF naught in kilojoule per mole. Okay, so the given mark for this question is 2. So this should be small calculation. uh, this is the calculation where small steps are required, so we will just use the general formula. Okay, the general formula for finding uh, the the general formula for finding the formation enthalpy here is um, sum of combustion enthalpy of reactants minus products. Well, let me write it in another. Sum of combustion enthalpy of reactants minus sum of combustion enthalpy of products. Okay, so this is the equation that we will use here. This formula is only applicable if all of the data here given is the combustion enthalpy. Okay, so if the data all here is if all the data here are the combustion enthalpy for each substance, then we may use this ideal equation. Okay, so simply using this equation, so del HF not. So first of all is sum of combustion enthalpy of reactants. Okay, so sum of combustion enthalpy of reactants. So since there are 3 moles of carbon and 3 moles of hydrogen, we just gonna use 3. Okay, we just triple the values. Minus 394 plus 3 into minus 286, not 96, 86, sorry, minus 296, 86, minus 286, sorry again, minus according to the formula, this is the sum of combustion enthalpy of reactants. This is the sum of combustion enthalpy of reactants minus the sum of combustion enthalpy of products. Okay, so the product is alone is this. Since this is 1 mole, so we are using 1. Okay, so 1 multiplied by minus 2058. So this is the sum of this is the sum of combustion enthalpy of reactants minus sum of combustion enthalpy of products. Okay. Isn't it the formula that we have discussed a little before? Yes. So this is the general formula for finding out the combustion for finding out the formation enthalpy. This is the general formula for finding out the formation enthalpy if the data given here are all combustion enthalpy. Okay, so if you work this out, then you will get this value plus 18 kilojoule per mole. Okay, so that's the answer. So here is one thing that we need to know, that we need to mention the sign. Okay, regardless of the sign, we need to mention whether it is positive or negative. We always need to mention the sign. Okay, since this is positive, so we will mention this sign, and we will mention the unit in the calculation. It is wise to mention unit in the calculation, but it is always um, compulsory to mention the sign. Okay, it is always compulsory to mention the sign. So, and here they didn't mention about the significant figures, so we will leave it like that. Okay, so here, that's the solution to this question. Well fellas, this is the solution to this question. So if you have any question, or if you have any confusion regarding this solution, please let me know in the comment section. Okay, so I hope that this solution has helped you in your problems. So if you have any confusion, if you still have any confusion regarding this topic, please let me know in the comment section. Okay, so if you have any other question, you may ask in the comment section. So that's it for today. Signing out, fellas. So best of luck for your exam. Stay awesome, stay cool, and as always, peace with chemistry.